So the question we have is to figure out where cosine of 3 theta equals 1 in the interval 0 to 2 pi. Now, I mean, there's kind of a brute force approach to stuff like this, just looking at the graph. But unless you're really good, it's not going to tell you where all the solutions are. So let's start out by trying to get the 3 theta by itself. Now we're actually going to go a little bit beyond the problem and solve this not just between 0 and 2 pi, but for everywhere. So I'm going to start by trying to figure out, trying to get theta by itself. So to do that, let's see, I've got cosine of 3 theta equals, give yourself some space here, 1. If I wanted to get rid of this cosine, I've got to undo that. And what undoes this is the cosine inverse. So I'll take the cosine inverse on the left-hand side, and I better do the same thing on the right-hand side. Take the cosine inverse. So the nice thing is that on the left-hand side, cosine and cosine inverse, those cancel each other out. I'm just left with 3 theta. On the right-hand side, though, I got to think a little bit harder. I got to figure out what angle has a cosine of 1. And it is, where's cosine equal to 1?
0 and 2 pi?
0 and 2 pi. Now, of course,
2 pi would not be included in this one because it's less.
Yeah, let's just stick with 0, right? But, and there's always a but, right? But to really get all of these solutions, you can't just say, oh, well, divide by 3 and get 0. Let's take a look at the graph and understand why. Here's the graph of the cosine. Here's our interval 0 to 2 pi. We want to know where cosine is equal to 1. And it's, in the interval 0 to 2 pi, cosine equals 1 just right there. And then again, 2 pi, etc. But that's not quite our problem. Our problem is where cosine of 3 theta equals 1. So let me shut off this graph and look at this one. This one has several solutions in the interval to 0 to 2 pi, right? In fact, it looks like it has 3 solutions. So we need to come up with all those. So how do you do that? Well, the trick is to realize that our initial problem has solutions here and at 2 pi and again at 4 pi. Basically, it repeats itself every so often, right? How often does it repeat itself? Every 2 pi units, right? Where k is an integer. So 2 pi, 4 pi, 6 pi, etc. So you have to include this term there, even though there's a 0 here. That's okay. So are we good with that inclusion of that term there? All right.
Yeah, I'm good with it so far.
Okay. Thanks, Zach. So that's just really 3 theta equals 2 pi times k. And now I want to solve for theta. So I'll multiply both sides by the reciprocal. On the left-hand side, I get exactly what I need, which is theta. On the right-hand side, I get 2 pi over 3 times k. Now, let's figure out the solutions that we're going to need. This is our solution in general, but we want a few particular solutions. So I'm going to plug in values of k and get out values of theta. Let's start with an easy one. Let's start with k equals 0. Well, if that's 0, I get a solution at 0. What about if k equals 1?
The answer would be 2 pi over 3.
2 pi over 3. Perfect. What about k equals 2?
4 pi over 6.
Close. 4 pi over 3. You only multiply the numerator. So maybe I should write it like this, 2 pi over, or 2 pi times k all over 3. And to see that, what you could do is write this as 2 pi over 3 times k over 1. That's how come the k is in the numerator and not in the denominator.
Okay.
Let's do one more here. What about if k equals 3?
Then it would be
Pi?
2 pi k? Or no, 2 pi?
K, it'd be 2 pi. It'd be 6 pi over 3. And you're right, you reduce that to 2 pi. Is that included as part of our solution? No, because we want theta to be between 0 and 2 pi. So these three are part of our solution. If you go the other way, k equals -1, that's not part of your solution. So the only thing that should be as part of your solution are these three right there. 0, 2 pi over 3, and 4 pi over 3.
Oh.
Now let's
So we
check
can't,
that.
okay.
Let's check that, right? So if we come back here, and let me turn on this graph for y equals 3x, let's check that we got the correct three solutions. Well, there's one at 0, one at 2 pi over 3, one at 3 pi over 3. We don't want this one because that's going to be 2 pi. And I didn't want to go all the way up to 2 pi. So those are my three solutions.
Oh, you made it look a lot easier than it sounded.
Okay, cool. Cool. Well, I'm glad to hear that. Is there anything on this that's still a little bit murky that maybe I can explain a little bit more?
I'll scroll through the questions later on, see if there's anything.
All right. Cool.
Professor, if you didn't do this on decimals, I would have only picked the first solution. I wouldn't.
Yeah, that's something that's nice about decimals is that you can see that there's more than one solution. And the way you get that extra solution is by including that plus 2k pi with all your work here. So you have to do that with all these trigonometric equations so that you get all these solutions. Now, sometimes if this number is less than 1, it spreads out the solutions. But if it's more than 1, it kind of pulls the solutions together. In fact, let me try and demonstrate that real quick. Let me put in an A here. That's a little slider. So depending on the value of A, now right now A is set to be 1. It looks like I got 2 solutions if you include or don't include that. But if I make this bigger, I get more solutions. But I can go to the other direction and make it smaller, and then it spreads out the solutions more because you're stretching the period. So now, look, I just got 1 solution. So,
Okay.
Yeah, good question. Good question.
Thank you.
No, thank you. So your follow-up question is tangent of theta equals 19. Let's look back at the previous one we had here. Now this one's a little bit more annoying because you got a 3 theta. But the way we start is still going to be kind of the same. That is, you want to get at this thing in here. And the way we did that is to get rid of the cosine. To undo the cosine, we use the inverse cosine. So what's going to happen down here? How are we going to get rid of the tangent so I can get theta by itself?
Oh, we're going to do inverse tangent.
Mm-hmm. So I'll do the inverse tangent on both sides. Tangent inverse. And what do I get? Let's start with the left-hand side.
Theta.
Theta. And on the right-hand side, I have no idea what the inverse tangent of 19 is. I won't pretend to do that in my head. My calculator's in radian mode. Actually, I think I can do it here. That's probably shows up a little bit better. Let me clear out some stuff. Again, my calculator here is in radian mode, so I want the inverse tangent, second tangent of 19. So 1.5 something. It's close to 90 degrees, close to pi over 2, but it's not perfectly there. So that's one answer. Now there's something that's a little bit peculiar about the inverse tangent, or it's going to be the tangent function. Cosine and sine, and secant and cosecant for that matter, are periodic with period 2 pi, right? How about tangent? What's the period of tangent?
1 pi.
1 pi.
Pi by itself.
Yeah. So I'll write this as the inverse tangent of 19 plus k times pi. So that, again, it's my general solutions here. Now, if we're trying to solve this in the interval 0 to 2 pi,
That means the only other number we can use is 1.
yes, exactly. So if you were to do this out, if we did k, we could do 0 and 1. Those are the only two that are going to fit in this interval. So I would get inverse tangent of 19 and inverse tangent of 19 plus pi. So let's just check that. I'm not even going to check it on the decimal, so I'm going to check it here. Let's take this and add pi. That's my other answer. So if you needed a decimal answer, you got that. Now to double check it, I should be able to take the tangent of that angle and get 19. Now I'm not going to do it by going up here and getting it that way. I'm going to use the answer key because that gives me more precision. I want this to come out to 19, and I want to hear, ooh, ah. Good job, Professor. So here we go. Tangent of second answer. So it's got all the precision of this. And come on, give me 19. Beautiful. All right, here's your part, right? Ooh, ah. All right. So it works. So that's another angle whose tangent is 19. You can't go any farther and still be in the interval 0 to 2 pi, so we're good. All right.
All right.
Great question. Great question. A good follow-up. Anything else I can help out with, or does that do it?
I don't think so. I was struggling a little bit with the 3.3 questions involving the theta.
Okay.
I think with this